Hi everyone, in this video we're going to talk about a non-parametric alternative to one-way ANOVA, which is called Kruskal Wallis test. It is a rank-based non-parametric test which is used to determine if there are statistically significant differences between two or more groups of an independent variable on a continuous or ordinal dependent variable. And your data obviously are not normally distributed. For example, in today's research, we're going to see a study in which a medical researcher has heard that certain anti-stomach ache medications can have the positive side effect on treatment of coughing in COVID-19 disease. The medical researcher would like to investigate the evidence with a study by using three well-known anti-stomachache medications labeled as A, B, and C. He rated the coughing severity on a scale of 1 to 10, with 10 indicating the greatest level. But something that needs to be considered about the Kruskal Wallis test is that it cannot tell you which specific group of your independent variable are statistically significant different from each other. It only tells you that at least two groups were different. Since you may have more than two groups in your study, determining which of them is different is important. And we can find out about that by using post hoc test if they were different. And as always, before doing the test, we need to check the assumptions to see whether they are met or not. To do Kruskal Wallis test, four assumptions need to be checked. First, your dependent variable should be measured at the ordinal or continuous level. Here, our data is ordinal on a scale of 1 to 10. So the first assumption checked. And second, your independent variable should consist of two or more than two categorical independent groups. And here we have three different medications named as A, B, and C, and 30 participants randomly were assigned to one of these three groups. And assumption number 3 says that you should have independence of observations, which means that there is no relationship between the observations in each group or between the groups themselves. And the last assumption is that you have to determine whether the distributions in each group have the same shape or not. Since when carrying out a Kruskal Wallis test, we compare the medians of our dependent variable for the different groups of the independent variable, we need that assumption to be met. However, you can compare mean ranks as well. It's just a matter of convenience. So anyway, let's get back to our example. First, to check the distribution of each group, you need to go to Analyze Descriptive Statistics and Explore, and put coughing into dependent and medication into factor box. And now click on plots, and we can check histogram and normality plots, and then looking at box plots, they're roughly the same. The distances between these are almost equal, since we're looking for similarity rather than to be exactly identical. And also the interquartile range. For C and B are quite the same, and for A is smaller. So as you can see, they're not identical, but they are similar. So that's what we're looking for, and we can say that we made the assumption. So we're good to go. And now to do the test, go to Analyze, Non-Parametric Tests, Legacy Dialogues, and K-Independent Samples. So on the window shown as tests for several independent samples, transfer the dependent variable or coughing severity scores into the test variable list box, and independent variable or medication treatment groups into the grouping variable box. And now click on Define Range button and enter 1 into the minimum box and 3 into the maximum box. These values represent the range of codes we gave the groups, and since we have 3 groups and we want to analyze and compare all of them, we started from 1 to 3. And the importance of this defining is that if we had, for example, 5 groups and we want to analyze just groups 2 and 4 and compare them, then you enter 2 into minimum and 4 into maximum box. And now click on Options, check Descriptive, and continue, then OK. So here is the result. In the first table, you can see rank table and mean of each medication effect on coughing. And so in the most important table, the test statistic, the amount of p-value is 0.33, which is greater than 0.05. So it says that there is no significant difference in between these medications on treating coughing severity levels of COVID-19 disease. And that's it. I hope you find this video helpful. And if you did, please like it and subscribe to my channel.